Welcome back to my channel. This is second video of probability. Here I will continue with the third problem because already I have given one explanation about probability and I have given two problems. I have solved the two problems in my first probability video, and this is a continuity video. So if you don't watch my first video, please watch it and come back. Then only it will be easy for you to understand. In this video, I will start with the third problem because already I have done first two problems in my first video. I have given the link in the description. Please check it. Now, the third problem is a bag contains 4 white and 5 blue balls. They are mixed thoroughly and one ball is drawn at random. What is the probability of getting a white ball and a blue ball like that? They have asked. Here, even though we have two subdivisions, I have already told you the total possible outcomes should be written above that. Okay. So, in this, what is the total possibility? Total possibility is total number of balls in this case. Total number of balls. So how many balls we have? 4 white and 5 blue. That means total number is 9. We have 9 possible outcomes in this case. We have written that number of possibilities as number of balls here. Okay, now, so the first subdivision. A white ball. So the probability should be found out using what is our requirement divided by what is the total possibility. Okay, so this is how it should be. So what is our requirement? A white ball. So number of white balls. Number of white balls equal to how many white balls? 4 white balls are there. So this is our requirement. Our requirement is 4 balls, 4 white balls. Okay. So therefore, probability of getting white balls. So probability of getting white balls is, what is our requirement? 4 divided by what is the total possible outcome? That is 9. 4 by 9. This is the white ball, getting a white ball probability. And the second one is getting a blue ball. So how many blue balls are there? Number of blue balls. How many blue balls? We have 5 blue balls. Okay. So that's all. Therefore, probability of getting blue balls is equal to 5 is our required divided by 9 is the total possible outcome. So this 4 by 9, 5 by 9 are less than 1 but greater than 0. So our answer is correct. That's all. The problem size is not there in the answer. Answer is even smaller than the problem size. Probability, if you are like interested in probability, you will get full marks in probability. Now the fourth question, similar type of third question. A bag contains 5 white, 6 red and 4 green balls. One ball is drawn at random. What is the probability that the ball drawn is first option green, second is white and the third is non-red? A small difference is there in this problem. I will explain everything. Listen carefully. So now the first step is we have to find out the total number of possible outcomes. So here we will write total number of balls. How many balls are there? 5 white balls, 6 red balls and 4 green balls. So totally we have 15 balls. Okay, so total possible outcomes are 15 in this case. Then the first one, first subdivision. Okay, so first subdivision is green. So first subdivision is green. So you know very well number of green balls. Very simple, number of green balls. How many green balls are there? 4 green balls are there. So therefore P of getting green balls. P of getting green balls is, what is our requirement? 4 divided by what is the total possible outcomes? 15. So answer is 4 by 15. That's all. Okay. So no difference in green, and when you find out white also there is no difference. So number of white balls. Number of white balls. How many white balls are there? 5 white balls are there. Therefore, P of getting white balls. So, what is required? 5 divided by 15. See, if you have 5 by 15, so it can be cut. So, in that case, you have to cut it. 5 by 15 will be equivalent to 1 by 3. You cannot keep it like this, 5 by 15 like that. Take it to the minimum. So, when you cut it, it will become 1 by 3. Okay. So, in A and B subdivision, green and white, there is not much difference. The difference will come in that non-red. There only the difference will come. Now I will explain this. Okay. So C subdivision. Subdivision C. Non-red. In non-red, you have two methods to find out. You have two methods to find out. Both the methods I will explain you. The first method in this. Okay. So the first method. Okay, I don't want to write like this. First method. There are two methods. Any one you can solve in the exam. Not required to do both the methods. But whatever it is, you have to learn it. That is why I am giving you. The first method. So number of red balls. How many red balls are there? How many red balls are there? We have 6 red balls. So what we are doing? P of getting a red ball. What is the question? Question is non-red. But what we are doing? We are finding out the probability of getting red balls. What is the probability? 6 by 15. 6 is the required red balls and 15 is the total possible outcomes. Now, what we want actually? P of getting non-red. Right? We don't want red. We want non-red balls. So I have already told you the total possibility, total probability is 1. There is nothing greater than 1 in probability. So when you add up everything, the final probability what you get is 1 only. If you add probability of getting white balls, probability of getting green balls and probability of getting red balls, it will be equivalent to, finally it will be equivalent to 1. So the total possibility is, probability is 1. 1 minus 6 by 15. So when you subtract that, 6 by 15 is getting red balls. But we don't want red balls. So we are subtracting that from the total probability. So that is equivalent to 1 minus 1 is outside. So when you take LCM, 15 minus 6 divided by 15, which is equal to 9 by 15. 9 by 15 means you can cancel this in 3. It will become 3 by 5. This is the required answer. Once again, I'll tell you. We want non-red balls, but for that we are finding out the probability of red balls and we are subtracting that probability with 1 because 1 is the total probability. So when we subtract that with that 1, we will get the probability of non-red balls. So this is one method of finding out non-red. Now I will teach you the second method also. Whichever you want, you can solve it in the school exam or wherever. The second method. The second method is total number of balls other than red. We don't want red, no? So what are the total possibilities of? So we had 4 green and 5 white, right? So 4 plus 5, which is equal to 9. 9 balls are not red. That one we have taken. Now, therefore, probability of getting non-red balls. Non-red balls. So what is our requirement? 9 by 15. What are the balls other than red? That is white and green. They are, when you add them, you will get 9. The total possibility is 15. Therefore, 9 by 15. So 9 by 15 was the earlier answer also. That is equivalent to 3 by 5. So you have to learn both the methods because you don't know where you have to use what method. That is why I am giving you both the methods. The fifth question. In a lottery, there are 10 prizes and 20 blanks. A ticket is chosen at random. what is the probability of getting a prize? So this is very simple mental math only, nothing great. But then the steps matter here. So now first one, total number of possible outcomes. That is the first thing, no? That is equivalent to how many possibilities are there? 10 plus 20. Therefore, 30 possibilities are there. Total outcomes. So how many number of prices? Number of prices. How many prices are there? 10 prices are there. So this is our required. Okay, and this is total possible outcome. Therefore, probability of getting a prize. Probability of getting a prize, that is equivalent to 10 by 30. I told you, you cannot keep it. You have to cut it till the prime number exists. So, I mean, after that you cannot cut. So, till there you have to stop it. So, 10 by 30 is equivalent to 1 by 3. That's all. This is mental math only. There is nothing more in this problem, but all the step matters here. Now the next question, it is known that a box of 100 electric bulbs contains 8 defective bulbs. One bulb is taken out at random from the box. What is the probability that the bulb drawn is, first one is defective, second one is non-defective? Okay. So now we need not find out the total. Usually in the total possible outcomes we will add and find out. Here no, no need. They have only given. What is that? Total number of electric bulbs. What is the total number of electric bulbs? We need not find out. They have only given it is 100. Okay. So now the first subdivision, defective. So how many defective bulbs are there? Number of defective bulbs. How many bulbs? 8 bulbs are there. So therefore, probability of getting a defective bulb is equivalent to 8 by 100. So when you cut it, 8 by 100 will become 2 by 25. You have to cut it and produce it. Okay, so that's all. This is about the defective. So when it comes to non-defective, again there are two methods, as like I explained in the previous problem. The second subdivision is non-defective. So two methods are there. Any one you can write in the exam. Two methods. The first method. The first method is number of non-defective bulbs. Number of non-defective bulbs. How many bulbs are like non-defective? 100 bulbs are there and that 8 bulbs are defective. So remaining 92 bulbs are non-defective bulbs. Okay. So remaining 92 bulbs are non-defective bulbs. So that is our requirement. And then P of getting a non-defective bulb. So that is equivalent to 92 divided by the total is 100. Okay. So when you cancel everything, you will get 23 by 25. So probability of getting a non-defective bulb is 92 by 100, which is equivalent to, this is directly we are finding out non-defective bulbs and we are taking the probability. So this is the first method here and the second method. Second method, we know already we have found out probability of getting a defective bulb is 2 by 25. So probability of getting a defective bulb, this we have found out in the first subdivision. Defective bulb is equal to 2 divided by 25. So I have already told you the total probability. See, probability of getting a defective bulb plus probability of getting a non-defective bulb will be equivalent to 1. So therefore here probability of getting a non-defective bulb So, because here there is no third case, you have only two cases. If you pick up a bulb, whether it will be a defective bulb or non-defective, only two cases. So, when you add up both, you will get 1. 1 is the maximum probability. So, 1 minus 2 divided by 25. So, take LCM 25 minus 2 divided by 25, which is equivalent to 23 by 25. That's all. So, in either method, same answer you will get, and any one method you can write in the exam. No need to write both the methods. Any method if you write also, it is correct only. The seventh problem is, in a survey of 200 ladies, it was found that 82 like coffee while 118 dislike it. From these ladies, one is chosen at random. What is the probability that the chosen lady dislikes coffee? Okay, so this is very simple. So total possible outcomes are total number of ladies. Okay, both are same. So total number of ladies, they have only given it is 200. Even if we find also 82 plus 118 is equivalent to 200. Okay, so now dislikes coffee. So that is, they have directly given 118 dislike it. So there is no need for the second method. Okay, so number of ladies who dislike coffee, they have given. So there is no 1 minus all that is needed. So dislike coffee is 118. Therefore, probability of probability of ladies probability of ladies dislike coffee is equivalent to 118 is required divided by 200. So when you cancel this with the 2, we will get 59 by 100. So this is the required probability. Now still 4 more problems I have, and I am making it as another video. All the links will be in the description. Please keep watching, and in the third video I will give 4 more examples of probability. There I will be covering the drawing card probabilities and all.